So good afternoon, an official welcome to you all from Cambridge. My name is Liz Woodham and I'm one of the members of the Enrich team. And this afternoon I'm going to be working with Charlie Gilderdale, hi Charlie, and Ems Lord, who is the director of Enrich. Hi Ems. We're really looking forward to doing some mathematics with you this afternoon. And just before we get going, we'd just like to say a big thank you to Trinity College here in Cambridge for funding the event so that it's free to you all to attend. Now, you may have been to one of these events before, and if you have, you'll know that what we usually do is work on some mathematics, work on some of our latest tasks together, and that's exactly what we're going to do today. However, rather than spend all the time working on our newest tasks, this time we are going to work on those new resources, but we're also going to share with you some curriculum linked resources from our mapping documents as well, and give you a little insight into some of those. We'll invite you to participate in the mathematics via the chat at various points, so we look forward to reading your thoughts and ideas that way. Now I'm going to attempt to share my screen. Here we go. Before we introduce you to our first task, we'd like to share a particular model with you that at Enrich we find really helpful. If you've attended Enrich events before, you may well have seen this. But this diagram here, let me just scroll down a little bit. I'm hoping you can see what looks like a rope in the right-hand corner of the screen here. This model was created by Kilpatrick and colleagues, and it comes from a book called Adding It Up, Helping Children Learn Mathematics, published in 2001.
You can zoom into it a little bit, Liz,
yeah,
just so that it's a little larger because the writing's quite small.
Is that a bit better? This model is helping us understand the characteristics of good mathematicians, how we can nurture mathematicians. In fact, the authors talk about mathematical proficiency. We like to think about it as nurturing mathematicians. So you can see there are 5 strands to the rope. Now, 2 of these, I think we would all agree, are very well recognised. Conceptual understanding at the top here and procedural fluency. Without a doubt, those 2 elements are really important in nurturing mathematicians. And I think teachers throughout the land, throughout the world would recognise those. Perhaps the other 3, though, get slightly less attention, and we feel they deserve just as much attention. So let's start on the left-hand side here, adaptive reasoning. A good mathematician can work logically and apply reasoning to mathematical situations. That's vital. Strategic competence. That's about being able to apply reasoning, but also the conceptual knowledge, the procedural fluency to problems, to situations that you've not seen before. Again, a key skill for a mathematician. And this 5th element here, productive disposition, that's about, well, do I believe that mathematics is worthwhile? Yeah, I do, I really do. And crucially, I believe that if I work hard at mathematics, I can get better at it. I think one of the things that we find very powerful about this model, and the image in particular, is first of all that each of those strands is the same size. Each element carries the same weight, if you like, but also the intertwining nature. So together, these 5 characteristics make the mathematician. Charlie, would you like to chip in there? Is there anything that I haven't said that you think?
No. Keep going. Thank you.
Okay. So we wanted to share that with you at the beginning because this model informs all that we do at Enrich. And as we work on the tasks during this webinar, we'd like you to try and keep those 5 elements in mind. Do our tasks offer opportunities for developing all 5 of those elements? We hope they do. It would be great if you could think about that as we work. So, Charlie, I'm going to stop sharing my screen now, and I think it might be time to have a go at our first task. Charlie has got something prepared earlier in true Blue Peter style, for those of you who know Blue Peter, the children's program. And we're going to have a go at this challenge. So Charlie has drawn there 8 boxes. Those 8 boxes are representing 4 2-digit numbers. And we've got 2 number sentences, 2 inequalities. So along the top there, we've got a 2-digit number being smaller than another 2-digit number, and the same underneath. Charlie, my challenge to you is this. Could you please fill those boxes in with the digits 1 to 8? So use each one exactly once, please, so that the inequalities are correct. Those of you participating, you could do this while you watch as well.
Can you hear me, Liz?
Yes, I can.
Okay, so as Liz said, we've come prepared. So there are my 8 numbers. Okay, so I've got 8 numbers, 8 cells. I think I can write 24 is smaller than 73, for example. I'm going to go crossing out the numbers that I've used. So I make sure that I use all 8. And then I can say that 15 is less than, 68.
Great. Thanks, Charlie. I think we'd all agree that those 2 number sentences, those 2 inequalities are correct. Thank you. However, what I didn't tell you is that in this challenge, there's a scoring system. So what we're going to do is we are going to give you a score, and the score is the total of the 2 2-digit numbers on the left-hand side. So in your case, it's going to be the total of 24 and 15.
Okay, and I get to the score of both because both statements are correct.
Exactly.
If only one statement had been correct, I would have only got that score. So I get a score here of 39.
Okay.
Which doesn't seem very large. And so I was putting quite small numbers here because I wanted them to be smaller than that. But what you're now saying is, actually, I want them to be as big as possible to get a big score, while at the same time being smaller than these numbers.
Precisely. So that's the challenge. For those of you participating, your first mathematical task of the afternoon, can you beat Charlie's score? Can you place those digits 1 to 8 in the boxes to complete? So the inequalities must be correct, but can you get a bigger score than 39?
Oh, that's too easy a challenge. They've got to get at least 2 or 3 times my score.
Nice.
So,
and even better, what is the largest possible score? When you post your suggestions in the chat, I think what we'd like to do is, can you post the score, but don't post the arrangement of the digits, because that gives us all a little bit of work to do. So let's give you a few minutes to have a go. Can you beat 39? Can you do 3 times 39? What is the highest possible total?
and one person, Liz, has already doubled my score, and one person's gone 3 times my score. So it looks like Fiona's in the lead at present.
This is true.
Ooh.
Now she's got even bigger.
See, Fiona's charging ahead.
I do like the fact that I think it was Ian alluded, he said his first attempt, which sort of seems to indicate to me that he's still beavering away, trying to get better. These are looking pretty good, aren't they, Charlie? What's the highest we've got? Oh, interesting. We've got 149 question mark.
Well, Alan's asking whether it's possible.
I wonder.
I think if you've got 149, we haven't explained the rules well enough. So, Alan, you've got to use all the numbers 1 to 8. You've got the left-hand side's got to be smaller than the right-hand side in both cases, so that you can add your left-hand scores. Trying to work out how you would have got 179.
149.
Sorry, 149.
Ah, no digit of 9. That's absolutely right, Ben. Yes, so we've only got the digits 1 to 8. Ah, that's where Alan went wrong. Thank you, Ben. Easily done, easily done. So what's the highest we've got? Let me scroll back. Let me say what we've got 127. A couple of people have got 127. I think maybe we can get a bit more than that, Charlie. What do you think?
Sorry, what was your question?
So a couple of people have got 127. I think that's the highest anyone suggested so far. And I'm saying I think it might be possible to get a little bit more than 127.
I don't think so, Liz. I think 127 is the maximum we can get.
Goes to show what I know, doesn't it?
Sorry, my blind is automatically going down, which is why it's making a lot of noise.
Oh, I didn't hear it.
Okay.
Oh, there's quite a few people. So I wonder if you feel as if you've got the maximum possible, I wonder how you would convince somebody else that it definitely was the maximum. Perhaps you could rehearse that in your head, chat to another member of the family who may also be watching. So Charlie, what do you think? 127 is the maximum.
Do you want me to try and convince you?
Yeah, why not? Try and convince me.
Okay, so I've written the numbers again, and I'm going to write 1 to 8 again to make sure that every number gets used once and only once.
Yeah, very sensible.
Okay, so I want the numbers in the tens column to be as large as possible. And so I want to use the largest possible numbers. So I'm not going to be able to use an 80 because I'm not going to be able to get a bigger number. So what I'm going to do is I'm going to put an 80 there and a 70 there. And likewise, if I put a 60 there, I'm not going to be able to get a bigger number on the right. So I'm going to put a 60 on the right and a 50 on the left. And that's quite nice. I've already got 120 points by focusing on the tens columns. And now whatever I do in the units column doesn't really matter.
No.
Because whatever happens, I've got 70 something and opposite 80 something, I've got 50 and 60. So what I'm going to do is I'm going to put the big numbers, the 3 and the 4 here. And of course, it doesn't matter which order I put them in. So it could have been 73 and 54, or vice versa. And likewise, the 1 and the 2 here, again, don't really matter where I put them.
Yeah.
And so this is the way that I get 127.
But there are a couple of different arrangements. Yeah.
So in terms of our rope model, Liz,
yes,
there was some reason. One of the strands of the rope model was to do with reasoning.
Yes.
And so I've done a bit of that. But the other one was about problem solving.
Yeah.
And so I made a decision that I was going to focus on the tens columns before I focused on the units column. But there was still the conceptual understanding and the fluency that comes from understanding, to be able to add and to understand what the inequality sign means. So this is an example, it seems to me, of a problem that satisfies everything on that rope. And at the end of the day, hopefully students get 127, feel good about it all, and feel that they've got a sort of positive attitude towards the subject.
Absolutely. Thanks, Charlie. That's really helpful. Thank you to those of you participating for your contributions in the chat as well. So this task, Charlie, is great for, I would say, upper key stage 2 and into lower key stage 3 as well. I think, and it's one that, as we said at the beginning, it's one that's been on the site in various guises for a little while. However, we've recently developed a follow-up task, which we'd like to share with you now, that perhaps, you know, sort of offers an even higher ceiling potentially. Charlie, would you like to, you look like you're about to say something.
Yeah, no, before saying that, I just want to say, often this is used in the class, this problem, as a game.
Oh, yes, thank you.
So what Liz and I have done is rehearse the kind of arguments that you might want your students to engage in before they play the game, so that they play the game with an awareness of what's significant and what's less significant. So when we suggest to teachers that they play the game, or when we do this with students, we normally throw a dice. And if you haven't got dice, Liz later, I think, is going to show you the interactive dice and spinner that we have. And often we suggest that students play it one pair against another pair. And the value of having a pair, a partner, is that then you've got to sort of explain and justify what your strategy might be. Which numbers, which cells do you fill in? And you can play the game where you go filling the cells as the dice is thrown, and you've got to decide, am I going to fill a number in the tens, a cell in the tens column on the left, or a cell in the tens column on the right, or am I going to do one of the unit? Or you can do what we've just done, which is you throw the dice 8 times, you make a note of the 8 numbers, and then you get students to see what the maximum score is that they can get. And then you go totting up the scores as you go along, and perhaps the first pair to get to 500 or to 1,000 wins. Anyway, Liz was telling you about a follow-up problem, and this so this problem that we've just done is called less is more, and the follow-up problem is more, less is more. So Liz, what do you want me to do here?
So, well, why don't we do a similar thing? At this time, of course, as you can see, we've only got one inequality. However, it's made, you know, slightly more to think about because we've got the sum of two-digit numbers on each side. Why don't we start with the same, just a challenge to start with, Charlie, so we can get a bit of a feel. Could you put the digits 1 to 8 into those boxes so that the inequality is correct?
Okay, so I've got a sum here, and I suspect if I add things like 24 and 53,
yeah,
I will get less than 71 plus 68. And I'm pretty certain of that because 24 is less than 71, 53 is less than 68. And I can also see that on my left-hand side, I can get less than 100. On the right-hand side, I got more than 100. So I don't really have to add them all up, do I, Liz?
That's really nice reasoning without actually going through the mechanics of the adding process. Okay, so Charlie, this time we've also got a scoring system just to make things a little bit more challenging. And in this version, we're going to say that your score is the total on the left of the inequality sign. So in your case, that would be 24 plus 53.
Okay, so just like last time, I wanted the left to be smaller than the right, but actually I want the left to be as large as possible. And I think, again, participants in this webinar are going to be able to do better than me. I think I've only got 77 points.
I agree.
I'm not sure people are going to be able to double my score, but they might get quite close to doubling my score.
That's a bit of a clue, Charlie.
Okay, so the challenge there is for everybody, can you do better than 77? And the score is going to be the result of that sum, but that sum has got to be smaller than the one on the right. And again, yeah, in the chat, if you could write what your score is without telling us how you achieved your score. And then we can give you some feedback if you've gone beyond what we think is possible. Sorry about my strange 6. Sorry, I'm laughing at Alan Parr's comment about needing some time. Okay, so we've got quite a few suggestions over 100 now.
Yeah. Once again, I guess I'd like you to think about how you would convince somebody that your total was the highest possible. And at the same time, you know, with our kind of teacher hat on, how might we expect students, we know, depending on the age group you're working with, what would you be expecting students to be saying in terms of a justification? How would they convince each other, for example?
That's it. That's really interesting. Vicky's highest number is 127, which is the score that we got earlier.
Yeah, that is interesting, isn't it?
Because of course, if we put 74 plus 53 on the left-hand side, which is how we got 127,
yeah,
it will be smaller than 82 plus 61.
Yeah, and Vicky's not the only one. Yeah.
It's interesting that some people have done even better than that.
Yeah.
So we know 127 is possible.
I wonder if there are a couple of people who got 127. I wonder if you did that by looking at what we've done before, or that's just it's coincidence that you.
Yes, I didn't remember this happening to us before. But that's
no, and that's an interesting, because I hadn't thought of using what we've done before. So yeah.
So Enrich made an interesting point about there being more than one solution. So just like before, where I could move the numbers in the units columns and it didn't make any difference to the inequalities.
I think is 134 the highest we've got so far?
It is, yes, it is.
Perhaps, Charlie, we could do a little bit of convincing with this one, but with our next version, perhaps we ought to leave the convincing to participants rather than, shall we do a little? So Charlie, there are quite a few people who are thinking 134. What do you think?
So the kind of reasoning that I would want students to do perhaps is again to be focusing on the numbers in the tens column. So I'm thinking to get the largest possible total, I'm going to think about the 5, 6, 7, and 8. And I noticed that actually 5 and 8 add up to the same as 6 and 7. So if I had 50 and 80 on one side and 60 and 70 on the other side, I'd be guaranteed 100, and I got the inequality right, I'd get 130 straight off. And so they're interchangeable, like Enrich is saying, or I should pronounce the name correctly, Enrich is saying, it doesn't really matter where I put them. So I can put, for example, the 8 and the 5 on the left-hand side. And notice that we couldn't put the 8 on the left-hand side last time, but this time we can. So I've got 80 and 50 on the left-hand side, which is 130. I've got 60 and 70 on the right-hand side, which is also 130. And now I need to make sure that the units on the right add up to a little bit more than the units on the left. So I've got 1, 2, 3, 4 left. They add up to 10. So I need more than 5 on the right. Well, I can have 6 on the right. I can put a 4 and a 2. And again, like Enrich says, it doesn't matter which order I put these numbers in. And once I've done the 4 and the 2, I must have 3 and 1 left. And so this on the left-hand side gives me a score of 134. And this on the right-hand side is a bit more, it's 136.
Brilliant.
So that's a kind of reasoning that I would hope students might start sort of developing. And of course, we've had the chance to rehearse this kind of reasoning. So it'll take some time, but it seems to us at Enrich that unless we give students the opportunity to work on problems like this, which require that kind of reasoning, they're just not going to develop those reasoning muscles. Yeah. Okay. Sorry, and like with your previous problem, after doing this, we imagined that they could play this as a game, again, throw a dice, work in pairs, and if you get this right, you get that score on the left. Of course, with dice, you can start taking risks and then find that the left-hand boxes add up to more than the right-hand boxes, and then you get a score of 0. But as you go accumulating points, you could be working towards a target of 500 or 1,000. And so hopefully it's an engaging problem that students enjoy thinking about.
Thank you, Charlie. Shall we take a peek at, so in our new more less is more task, which we will show you very briefly on the site in just a few minutes, we've got 4 different challenges as part of it. So the first one we've already done. Charlie and I would like to share with you the second one, just to give you a little taste, but we won't give away the solution this time. We will leave that up to you, something for you to take away and think about. So here we go again. This time we've got the difference of 2 two-digit numbers has got to be less than the difference of 2 two-digit numbers. Charlie, would you like to place those digits 1 to 8 in the boxes so that the inequality is correct, please? And then we'll think about the scoring. Or do you want to go straight in with the scoring? How confident are you feeling?
No, I'm not going to go straight. But what I'll do is I'll get a large difference on the right.
Right. Yeah, to play safe.
I don't know. If I go for 76, take away 12, for example.
Nice. Okay.
I'll have a large number on the right.
Yeah.
Whereas if I have something like 45, take away 38.
Yes.
I'm going to say 45, take away 38. I've tried to do it so that the subtractions are nice and easy for me. I think I get 7 is less than 64. So nice. I definitely get 7 points there, but that's 7 points is not very many. I'm sure everybody could do much better.
It's not very many at all. So this time the scoring system is the result of the subtraction on the left-hand side. So let's give you just a couple of minutes to have a little think about this, but we won't be giving away the solution this time. in a similar way to last time, if you'd like to post your scores, but don't give away the arrangement of the numbers, that would be fantastic. I wonder if anybody's got more than 7 yet, Charlie. Oh, definitely.
Everyone's doing better than me, but I don't think anybody has got the maximum score yet.
That's right, Enrich, it is. In the example on the screen at the moment, the score is 7. Yeah, so it's the result of the subtraction on the left. We've got a couple of scores that are in the 40s. Oh, Stephanie's just shot the highest total up there. Let's just spend another minute, shall we, Charlie? And
the good news is everyone understands the instructions because no one has gone beyond the maximum possible.
Agreed.
If very few people have got the maximum, Liz, perhaps we should consider sharing our strategy. Don't know. Because they've still got other problems in the
task itself, I guess. But it might be that we just haven't got quite enough time for people to have thought about it long enough. I think we should stick to our guns and let people think about it. As you say, it looks like everybody's got the idea, because nobody's gone over. I think we ought to leave it there. Those of you who are beavering away still, I guess we're going to now ask the impossible of you to pause and leave that challenge to go back to at a later date. Share it with your students tomorrow, and then you've got an excuse to think about it more.
Would it be helpful to tell them what the maximum is so that they know what they're working towards?
Yes, okay.
Okay, so the people who've got 61 have found the maximum. So that's tonight's challenge for everybody. Can you get 61?
So I think what we would like to do now is, and again, in exactly the same way, you could play this as a game with a pair on a pair, as Charlie described earlier. Let's have a little look now. Charlie, would you mind stopping sharing your screen? Thank you very much. Brilliant. And what we're going to do now is go back to the Enrich website. And take a look at these tasks on Enrich. These two, as we've said, are some of our most recent tasks, and so you could find them in our past features, but we'd like to particularly remind you, you didn't necessarily know, we'd like to inform you that they are both live tasks. So for example, if I go to the primary teacher homepage and click on this box and the top blue box on the live problems link, I'm taken to a selection of problems which don't have solutions currently, and you can see that less is more and more less is more, the tasks we've done today, are both there. So if you have a go at these with your students, please do send in their reasoning to us. We're always looking for well-explained solutions, as I say, the reasoning behind an answer, not just an answer. You can see that there are a range of tasks in addition to the two we've tried today to have a look at. If I show you the equivalent page for secondary just briefly, so here's the secondary teacher homepage, here are the live secondary problems. Again, you can see here that more or less is more is up there. Our math dokus, which you may well have joined us in having a look at last time we did a webinar. And there are some lovely post-16 tasks as well there if you teach older students. We said that part of the time today we would spend having a look at some linked tasks from our mapping documents. Now, obviously, the tasks we've worked on today, less is more and more less is more, are linked to place value. So I'll start off sharing a primary task, and then I'll hand over to Charlie and he'll talk you through the secondary curriculum document and a linked task. So hopefully many of you know that we have a mapping document which is curriculum objectives linked to Enrich tasks. We're back at the primary teacher homepage, and I can go straight to the mapping document using this link in the purple box on the left. And that's going to bring up a Google Sheet for us. Hopefully this is familiar to at least some of you. Along the bottom here, you can see that there are different tabs for different areas of the curriculum. But as I say, we're focusing today on number and place value, which is the current tab. And if I just scroll down, we can show you where we've linked the less is more tasks. So remember, this is the primary mapping document. So we're suggesting that less is more is a great task that uses all your knowledge of place value. Now we've popped it into year 5. This is the dilemma at Enrich. Often we struggle to identify a year group which is the perfect year group for a task. That isn't what we're saying really. We're saying it's great to use with year 5, but it wouldn't stop you using it with slightly younger or slightly older students too, of course. So another few tasks that I'd like to highlight for you, in case you don't already know about them, are featured here in the section which is about understanding place value. So you can see here, we've got, they happen to be in the year 4 column, but again, they could be used with older students. I'm going to show you very briefly this one here, which is called nice or nasty. You may know this. It's a similar setup in the sense that you've drawn some boxes. This time you're rolling the dice just 4 times. You're placing a digit into one of your 4 boxes, and you're working competitively to try and find, for example, the larger number. Again, it would be nice to do this a pair on a pair. There are various versions of the game. So as I said, the first one is about who can get the larger number. You could do the smaller, you could set a target, you could add a decimal point, you can play the nasty version, which is about throwing the dice, and you can choose whether to keep that digit yourself, or you can tell somebody else to put it in one of their boxes. Or a cooperative version where you throw the dice and everybody decides where the best place for that digit is, whose box it should go in. So that one's nice or nasty. Incidentally, you can see that this is a curriculum linked resource because of these lozenges on the left here. So not only actually is it linked to the primary document, but we also feel that it's excellent for secondary students too. Going back to the curriculum map, let's have a really quick go at another task. It's called Dicey Operations in Line. Now, I'm not going to show you on the screen to start with. I'm going to share, I'm going to stop sharing my browser, and instead I'm going to show the visualizer. Charlie, can you nod at me? Can you see those boxes? Okay, so what we're going to do is we're going to throw a dice 9 times. Now, as Charlie mentioned, I'm going to show you where the dice spinning, the dice and spinner interactive is on Enrich. I'll use it now, and then in a second, I'll show it you when we go back to the site. So as I roll, you may like to join in. If you draw your sets of boxes, So we're adding three-digit numbers. As I roll, I'm going to call out the number, and when I call out the number, you've got to decide which of your boxes to put that number in straight away before I roll again. I'm going to use a 1 to 6 dice, but you could use a 0 to 9 dice. Our challenge is going to be to see whether we can get as close to 1,000 as possible. How close to 1,000 can we get? I'm going to have a go. Charlie, I don't know whether you're going to have a go, but we won't be able to see your screen. But maybe we could have a little competition who can get closest to 1,000. And those of you participating, join in too, should you wish. Are you ready, Charlie?
Sorry, just sorry, I was responding to somebody in the chat.
Oh, sorry.
Can you remind me, are we using 1 to 6 or 1 to 9 or 0 to 9?
Good question. We're going to use 1 to 6.
Okay, fire away.
Right, here we go. First roll is a 5. Where shall I put my 5?
I mean, if you wanted to, Liz, oh no, I was going to say you could share the spinner and no.
I can show the spinner in a minute. That's fine. Yeah. Okay. Next roll. 4. Next roll. 5. Next roll. 4. Next roll. 4. Oh, I want some low numbers. 3. Ooh, I'm going to risk it. I'm intrigued to see what you're doing, Charlie.
Well, I'm not doing the same as you.
Okay, good. 1. 4. A lot of 4s today. And the last roll is a 6. Right. So let's make a quick tot up. 4. Ooh, I'm not sure if I've done my arithmetic correctly. Those of you participating can tell me. Charlie, what was your score?
Well, I haven't added them, but I can tell from the numbers that I've got more than 1,500.
Yay! So, I win.
No, I've got more than. Oh, sorry. I thought. Oh, were we trying to get the maximum? No. We were trying to
get as close to 1,000 as possible. Were you playing a different game? Is that your excuse?
Yes. Okay. Well, we've got 2 challenges for everybody then.
Yes.
Could Liz have got closer to 1,000 than she did?
Yeah.
And could I have got slightly higher than I did? I've got about 1,520.
Okay. So for a few minutes, choose one of those challenges. Either decide whether you think I could have got close to 1,000, or decide if you've got time, you can do both, or decide whether Charlie could have got more than 1,520. You think?
Yeah, I've been very lazy so far. I'm going to add them, and I'm going to tell you, I've got 1,530.
1,530. Okay, there we go then. So can you do better than that as a total using those digits? So we've got. You can definitely do better. I might write the digits up here just in case that's helpful.
That explains why you put that 1 in the hundreds column. I didn't understand why you did that.
5, 5, 6. Is this right? Have I got 9 numbers? 3. Yeah, I think that's right. So those are the digits we're working with. Oh, Stephanie got with me. Oh, Kathy, Kathy's got even closer. Oh, Rebecca's got 28 away, so even closer. Looks like Rebecca got the, so did you say you got 1,530, Charlie?
Yes.
So it looks like Rebecca agrees with you in terms of, I don't think anybody's managed to get higher than that yet.
I think I can get higher than that.
Can you? Interesting.
About 200 higher.
Oh no.
Did you say some people got 28 away from?
28 away from 1,000, yeah.
Yeah, I think that's the best I can do too.
So Stephanie's increased our highest possible total, 1,728.
Yeah, I think that's right.
Let's see, did you? Yes, I think I agree with that.
Yeah. So yet again, so I'll just speak while everybody's working.
Yes.
I think the rope model captures a lot of what we're doing. So Liz gave us the numbers initially, and we were having to make decisions about which cells to place, and we saw Liz making those decisions as she went along. If she'd been playing with somebody else, she would have had to talk about where she and her partner would have had to agree, and therefore, and articulating your reason is really helpful. And then so we're touching on the strand to do with reasoning, with problem solving, at the same time as getting children to add and become fluent at that.
Yeah.
Oh, sorry, my light goes out if I don't move around.
Just let me very quickly, before we pass over to Charlie again, let me show you the spinner on Enrich. So if you go to enrich.maths.org/6717, you get an interactive Dyson spinner, and you can change it to, if for the dice it can show dots, it can go up to, and you can change the, clicking on the purple cog allows you to choose what you'd like it to display, just so you know.
Liz, could you go to Nice or Nasty tab again?
Yes.
Because at the top there, you've got a link to the Dyson spinners.
Yes, thank you. Yeah.
But also the other way to get at the spinners, I think, is to go to the home page.
Or did you mean the secondary teacher homepage?
I think I possibly mean the secondary teacher homepage, sorry. And in the green box, labeled secondary curriculum, at the bottom there, you've got interactive resources. And I think there are 3 generic resources at the top, and one is the Dyson spinners interactivity. So that's a nice, easy way of finding it.
Yeah. And there's an equivalent link on the primary teacher homepage.
Yes.
So there's that was the primary curriculum mapping document. And so we've had a little go at a couple of place value related tasks. Further down as well, going right back to our problem solving section, we've got a really nice task, number lines in disguise, which we've suggested is great for year 6 again and above. And Charlie, I believe this is also in the secondary mapping document, isn't it?
Yes.
Would you like me to navigate to the secondary mapping document?
Well, I've already opened it on a tab. So
okay, so you share your screen.
Yes. Okay, can you see the home page there?
Yes, I can.
Okay, and if you click on secondary teachers, there's a link here to the secondary curriculum page. And just like Liz has a Google document for the primary curriculum mapping document, we've got one for the secondary, and I've already clicked on that. It takes a little while to upload, so I did that earlier. And just like in the primary mapping document, we've got different sections. So we've got an algebra page, a geometry page, and so there'll be different headings and different statements linked to those headings in a very similar way to Liz's. And if I go back to number, one of the sections is our place value, integers, order, even rounding. And here you can see dicey operations, which is very close, very similar to nice or nasty, except the sums are presented in a different way. And we also have more less is more. And like Liz said, number lines in disguise also appears here. And just to give you an idea of, well, both to explain why it appears in both, you get a number line and you get asked to work out what the value of the dot is. And you've got some information about the number line. In this case, I've got the information that 10 and 20 are sort of 5 steps apart. So I can go back another 5 steps, 1, 2, 3, 4, 5. That's going to take me down to 0. So I think the black dot is -4. So I'm going to reveal the answer, and that's what it is. Now, this will be sufficiently challenging for some secondary students, but a lot of level 1 work might be more suitable for primary school students. But then as you go up the levels, it starts getting harder. So we've got a fraction there. No, we don't. That's 11. Maybe I'll, okay. So you're working out how many steps there are. I think there are about 8 here, and that's a difference of 16, so you can work out what it is. And now, what do we have? 1, 2, 3, 4, 5, 6, 7 steps. Oh, 1, 2, 3, 4, 5, 6, 7 steps, and a difference of 11. Yes, that's a little bit more challenging. So, so there were going to be 7, so students would have to divide 11 by 7. Maybe think about, well, 11/7 is 1 4/7. And so going from 10, you go to, what did I say, 1 4/7. So that'll be 11 4/7. This will be 12 8/7, which is 13 1/7. And then 14 5/7. I hope I'm doing this right. 15 9/7, which is the same as 16 2/7. And then add 1 4/7, you get a 17 6/7. Yes. So that would be one way of doing this. Do we go one more level? That looks hard. And that looks harder. If you go to the teacher's resources, we've written down what happens at each level. So as you saw in level 1, there was a small negative number. I think the first answer was -2. At level 2, you started getting fractions, but fairly simple ones. And then level 3, it started getting harder. You had fractions and you had negatives. And then level 4 and 5 is more of the same, but the numbers are further apart. So the reason we wanted to show you not only more less is more, which is a very new problem, we wanted to show you where these problems lie on our mapping documents, so that you can see whether what's around that you might want to also do while you're working on place value with your students. For those of you in secondary schools, you may be thinking about wanting to use the less than and more than signs a bit more. And there's a nice problem here in the statistics page, which uses that, called unequal averages. So this is not about place value anymore, but it is about having less than signs, and it also involves sort of playing with numbers. I'm not going to talk about this problem because we're running out of time. So I think I'm going to stop sharing and pass on to Liz.
Thank you very much, Charlie. Yes, we're rapidly coming to the end of our time together. I'm just going to share the Enrich site one last time to finish off. So here we go. Let's go. Just a very quick reminder that the rope model that we were talking about, you can find here on our what we think and why we think it pages. I've happened to have the secondary one up here, but there's a reminder of the rope model. And if you search rope model on the Enrich site, actually it would come up in a few places. So I hope you feel that even those last couple of tasks that we've used with you address many of those elements of the rope model. We just wanted to sort of finish by thanking you all for coming. If you would like to, please do send us your feedback. That's important. And Ems has already put a link to the feedback form in the chat. Thank you, Ems. If you'd like to hear about more of these events or keep up to date with us in general, the best thing to do is right at the foot of any Enrich page, you've got links to our Twitter account, and you can sign up for our email newsletter. Keep an eye out for our advent calendars, which will be published on the 1st of December. There'll be a primary one and a secondary one. So if you don't want to forget about those, that's another good reason to follow us on Twitter or sign up.
Liz, can you just point your cursor at where the registration information link is?
Yes, sorry. So this is the link to Twitter. Can you see that? Can you see my
Yes, cursor? Yes.
And then at the bottom there is the link to the email newsletter. Thanks, Charlie. So
will the recording be uploaded on a particular page?
Thank you very much. So if we go up to the events page, which is possibly where you found the link to book on today, you also get there's a link here to previous webinar recordings. If I click there, we have put up a page ready. So the November 22, the link is enrich-live-nov-2022, and the recording will go there. All the little bits and pieces that I'm talking about now as well, the links to various things, are on the PDF of a couple of PowerPoint slides, just so that you remember as well.
But an easy way of finding this page, can you just point to where the events link is at the top menu there? Yeah. Okay.
That's how we got there, from the events page.
Great. So
thank you very much for participating. We've enjoyed working mathematically with you, and thank you again for Trinity for funding today's webinar. We look forward to seeing you again in a future event. Thank you.
Thank you, everybody. Bye-bye.
Bye.